Hey everyone, so today I'm going to be reviewing the all-new Oscal PowerMax 3600. This is by far the heaviest thing that I have ever reviewed on this YouTube channel. This thing is like a gigantic power bank that's supposed to supply 3,600 watt hours of battery power. 100 pounds. Ooh, this feels elegant. Like we've got a solar blanket. All right, here we go.
Sandals.
Both hands. Oh. Here we go, baby. Down we go. Okay, so this thing is pretty much massive. We've got standard fast charge USB ports here all over the front of it. We've got USB-C, standard 12 volt plug, or like the old timers would call it, cigarette lighter plug. Oh, these are actually DC outputs. I wonder if it came with any like double-ended cables to use with those. And also we've got standard prongs to output 12 volts at 30 amps. That's actually pretty stinking cool. What's under this big old flap? Ah, this is one of them great big 120 volt plugs. So this is going to output 120 volts, but also up to like 30 amps. So we've got 3 standard 15 amp 120 volt plugs, and then we got one great big 30 amp 120 volt plug. So what do we got here under this end flap? Could probably save myself a lot of hassle and just look at the instructions. This thing actually advertises being able to daisy chain it to other battery banks that look a lot like this, up to like 50 kilowatt hours of power. That's most likely going to be for chaining more of these big old coolers together so that you can have a lot more battery storage. So on the back side of it here, we've got solar car input, overcharge protection, so it's probably got a big old circuit breaker here in the middle. And then we've got a 110 volt charge port, assuming that's, yeah, right there, 100 to 120 volt AC charge port. So it's got what looks like an XT60 connector for inputting DC voltage. It looks like it'll accept 11 to 150 volts DC at up to 15 amps. Total output power, 3,000 watts. So it's going to do 3,600 watt hours, but it won't actually output, 3.6 kilowatts all at once. However, it does say it will do 3,000 watts. And the battery capacity is 48 volts, 75 amp hours. I almost missed this box. This was kind of tucked away in there hidden a little bit. What all did this thing come with? Because this is pretty exciting if it's got some, and it does, some like proprietary cool wires. What do we got here? Ah, this is some wizardry so that we have the accessories to hook it directly to a solar panel. This feels like a really heavy duty 100 volt cord. We have the final cord here. This is a cord so that you can charge this thing off of your car's cigarette lighter. All right, so we've also got a rather decent product manual. I'm probably going to go through this at some other time. Oh yeah, here we go. Here's what the plugs on the end are for. It's for daisy chaining the coolers together, so you can have like additional battery banks. I remember this thing originally said it could go all the way up to 50 kilowatt hours of power. How do you turn it on? Oh, how about this big button right here that says on? I hope this thing doesn't like blast me into the ceiling. Holy smokes. This thing, it is actually registering its remaining power in days. It's currently sitting at 63 days remaining. Here, we've got a meter that's going to show us what's coming in and what's going out. So if we had a solar panel hooked to this thing, then it's basically like its own complete power plant. What do we got here on the front? Is that going to be a light? Just in case you need to run a light for 178 days or maybe 2 or 3 years. Now, one other thing that I'm immediately noticing is this little Bluetooth logo right here. This thing is going to have some sort of an app that we can install on the phone that's most likely going to give us all of these stats as well. Oh, look here, it's actually got the carrying handle, the big red button on the bottom that pops this out. So you can actually take this thing and pull it around just like that, and it's almost like it doesn't weigh 200 pounds. All right, so let's start with something like really silly and small.
Silly.
Yeah. Well, it's the Hacko FX 951. That's like that. Okay, this is a 70 watt station. Oh yeah. Okay, we got to turn it on first. So there's the AC on button. Wow, the days drops significantly whenever it's running the inverter. it now shows that we are outputting 60 hertz. Look at that, 70 watts. That's pretty accurate. All right, so we're gonna see what this thing does whenever we plug it in to charge it. Whoa. That says 4 minutes. There's no way that's true. Oh, 3, okay, that's more like it. It just changed up to 3 hours.
It's about to draw 400 watts. Gonna take up to 500 watts.
Look at this thing.
Going for 600? It's going to 600 watts.
Okay.
Gonna stop it?
Oh, listen to the cooling fans kicking on. Oh, we are over 800 watts of charging power. It's fixing to charge this thing from 62% to 100% at 1,000 watts, and it's only going to take an hour to charge it.
No, it's still going. 1,100 watts.
Oh, whoa, 1,100 watts?
1,200 watts.
1,200 watts. Oh, come on, you're not going to throw a breaker, are you? This...
It's going to do it. 1,300 watts.
Listen to this thing screaming.
There's 14. It's going to do 1.5. There we go, 1.5.
Oh, this is cool. Listen to the fans.
1.6.
Listen to the fans screaming.
1.7.
All right, so we're going to charge at 1.7 kilowatts, and it's going to charge this monstrous battery bank full in 43 minutes. Is it hot?
No, it's moving a lot of air.
Oh yeah, that thing, it is really moving some air.
Intake on one side, out the other. It's got the push-pull.
I hope you all can hear this thing's internal fans screaming. Yeah, there we are. 1,800 watts of charging power. That is just completely nuts. So let's see what happens if we switch this thing from fast charging to slow charging. All right, so now we're on what is called slow charging. And now instead of drawing like 1,800 watts, it's going to charge at 1,100 watts, which, you know, that seems just a little bit more reasonable. All right, so let's get the most important part of life out of the way here. I have no idea what this thing draws, but it's probably upwards of like 800 watts because it'll heat a cup in like seconds. Oh, I was a little bit wrong. So it's going to draw about 1,400 watts.
Light work, no reaction.
Oh, listen to that thing. All right, so it's going to run 1,500 watts for 2 hours, and we're at 98% battery, so that is absolutely 3,000 watt hours. Like, holy smokes. No more will I have to brew coffee on a barbecue grill during the hurricane. Ah, yes. It's like magic, only it's French vanilla coffee. My precious. Precious. I brewed a cup of coffee and didn't even lose 1% of battery power, so that means I could brew 90 more cups of coffee. So it is now about 8 a.m. on a Sunday morning, and I want to find out how long the PowerMax 3600 is going to run our refrigerator the next time a hurricane comes through and knocks our power out for 5 or more days. The tag on the inside says it's rated for 115 volts at 7 amps, which is actually quite a lot. I know a lot of factors are going to affect this, you know, how often the door is open and closed, how much stuff is in the refrigerator, what the ambient temperature of the room is. There are a lot of determining factors here that are going to, you know, change how long this power bank will run this appliance. But I'm doing this on a weekend so that I've got all 5 family members home. We're going to have, you know, people will be opening and closing the door. It'll be sort of a normal day for this refrigerator. All right, so here we're starting out at 100% power with an estimated 99 days remaining. Kick the AC inverter on. So with the inverter idle, we're sitting here with an estimated 6 days remaining, and I'm gonna connect my refrigerator. Yeah, I do like having remote access into this power bank because I can actually keep an eye on this thing no matter where I'm at in the world. I don't really like that it's reaching out and connecting to some external server. I'm going to do some work to see if it can be used just locally with like Home Assistant. Here we go. I've got the app opened up on this phone, and we're sitting here with an estimated 5 days remaining. I'm starting the timer at about 8:10 in the morning on Sunday, and I'm going to see how long this thing will run and update you as to what happens. Okay, so don't laugh at me using an iPhone. It's now about 10 minutes after noon, and we are at 87% battery power. I'm a pretty long way away from home, but you can see here, I'm gonna capture the screen. You can see, I can tell that we're drawing still 150 watts of power, and the estimated time is 4 days remaining, and we are at 87%. And if I wanted to, I could actually just click the refrigerator off from here. Wouldn't that be kind of neat? All right, so we're at about the 12-hour mark. It is now 8:27 in the evening on Sunday. It has been a really active day for a family of 5. We've made it through breakfast, lunch, and dinner, as well as all the other in-between open and closes of these doors. We are at 51% remaining with an estimated 3 days. And again, it is sitting here with the compressor satisfied, and it is just sitting here idle. I'm actually going to go to bed and leave this thing hooked up like this, and it shouldn't run near as much through the night, but as it looks through a really active day, we're looking at about 50% used in 12 hours. So it's really promising for making it through a full day. I think if we weren't using this thing, like, you know, if we weren't opening and closing the doors, or if we just had it running a deep freeze, I think we would probably get 3 to 5 days out of it, but I'm really not sure. So let's see what it looks like in the morning. All right, so here we go. It's about 8:30 in the morning now on Monday morning. We are at 9% battery power, and that's the 24-hour mark. I did expect it to do a little better than that, but we had one teenager through the night that had, you know, he was opening the door here and there. So it wasn't just like a straight 12 hours without the door being open, but at 9% battery power, I really don't care to run this machine any lower than that, so I'm going to move on. So during and after Hurricane Ian, we were without power for about 5 days, and all I have is a really old generator that I did not trust to run any of my work equipment. We had trees uprooting in the backyard, and the wind was howling, but you know, I really just needed to solder. So I'm wondering how well this thing will run my entire workbench setup here. Now, this is absolute maximum power draw. I've got my hot air station coming in at 1,000 watts. The DC power supply, if I really loaded it down, it would draw 380, but it won't, so we can just kind of skip that one. Ultrasonic cleaner, 50 watts on the heat, 80 watts, blah, 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 blah. So all this stuff combined, if I use the maximum power, everything maxed out, I'm only looking at about 2,100 watts total on. I'm going to be starting at about 91% battery today. Turn the Wi-Fi on because we're going to need that. The app for this thing is totally sweet. You can control this box from anywhere in the world. That is switching the outlets on and off, seeing where it's at power-wise, seeing what your input output is, what your percentage is. I'm going to turn the AC power on. I'm going to turn the AC power on. Wait for the click. All right, now we've got the AC power outlets here live. I'm going to start with, oh, apparently that was my lights. So let's get this moved over and plug it in. And since it's long, let's go way over here. All right, there we've got our lights on, and that's also my 2 monitors just powered, along with my laptop charger. So now we're drawing 80 watts of power, estimated 30 hours remaining. The next cord here, I think, has the majority of my tools on it. Ooh, that's a shorter, much shorter. All right, let's just move the whole project over. All right, so my next cord, that's gonna be my PC and some other ruckus. Not too tight, please. Didn't plan this out very well now, did I? I'm gonna need just a little bit more plug-in space here. So let's get a surge bar hooked up, shall we? We'll slap us a surge bar on top. All right, so that's got the ultrasonic cleaner hooked up. Oh, we cannot forget the DC current meter. I'm just gonna plug the DC current meter into the first available USB plug here, and then turn that on. Yes. All right, so that has everything switched over. I'm gonna turn the ultrasonic cleaner on, and you know, let's just go ahead and set this thing to start warming up. There we go. All right, so we're now up to 200 watts total, and it's estimating 13 hours remaining to run 200 watts. So that's pretty cool. Now also keep in mind that we're starting at 91% power. This isn't like a jammed full power pack. Now it is worth mentioning, this thing is rated to have like 3,000 or 3,500 cycles before you get down to 80% battery life. And if you bang that away on the old calculator, you'll find out that that's like 9.5 or 10 years. Pretty stinking incredible. All right, let's turn on some tools. I'm gonna start with the Hacko. Soldering iron's coming on. That put us up to 365 watts, right? All right, so we're burning up about 300 watts of power now. Beep. The iron is up to temp. One of the irons is. And we went back down to idling at 240 watts. All right, I'm gonna boot the computer up. So the computer is up and running. I'm gonna flip on the hot air station, turn on the DC power supply. What are we sitting at now? Oh, still just under 300 watts. I know what you're all thinking. What's it gonna do when he picks up the handle on that hot air station? Well, all right, here we go. Hot air station. All right, got the hot air set on 220 degrees C with an airflow of 119. And boy, it surged up to 1500 watts, I seen. This is blistering hot. Yeah, I see we're tapping 1500 watts a draw. Let's hit 450 degrees. Come on, baby. 1100 watts. I can hear the fans spinning on this thing. It's a that's going to be to keep the inverter cool. I am getting some flickery out of this light up here. That's going to be, I don't know if that's going to show up on camera, but I am getting some flickering whenever I've got a really, really strong draw on this. But to be completely fair to this machine, this happens very oftenly running on utility power. All right, so there's what we're looking at. 300 watts, 1500, 300, 1000 watts. You know, we're hanging right around, 1500 watts or less of power. And that is with soldering iron is hot, hot air station is hot, both of my computer monitors on, laptop's charging. What else am I missing here? Oh, don't forget that. Wait, did I forget to plug it? I forgot to plug a light in. Dang it, watch me burn myself. Ha ha ha. All right, fans spinning down. I still got the hot air blowing 430 degrees C with an airflow of 40, and it's just kind of tapping 1500 watts here and there to keep the hot air up to temp. And that's actually pretty dang acceptable, really. These LED light bulbs, they are really prone to flickering whenever the hot air station is picked up. And out in the old shop, right out here on the other side of the wall here, all of the lights flickered when I ran this hot air station. And when I first got that hot air station, it made me wonder about the hot air station. It's causing some dirty power. It really is. All right, so now we're down to 89% on the battery. I've managed to drain 1% out of it here. And it is now estimating 9 hours remaining from this level. So I'm actually going to run everything like this for a good long while, and I'm not going to cover this all on video because, well, 9 hours would be a really, really, really boring video. All right, it's about, a quarter after 9 o'clock at night now, which makes for almost a solid 10 hours of running everything here on the bench on the battery power supply. That's not a whole lot of hot air use. That's a medium amount of soldering use, which, the Hacko station doesn't seem to raise the wattage all that much, although I know that it does. That is also keeping the ultrasonic cleaner hot all day long. And so what are we at now? We're at 24%. The machine is estimating 4 hours remaining, and sitting here at idle with a light on, computer on, laptop recording this actual video, my workbench computer is on. It's sitting here at about 130 watts idle. So just for good measure, let's pick up both irons. Wait for the beep. Come on, baby. All right, so 250 watts to run both irons. Of course, that'll level out once it's, once they're hot. Let's pick up the hot air, shall we? This should put us up to around 1500 watts. 1300, 900. Strange. Sometimes it gives me 1500 watts, sometimes less, but there you have it. We're going to idle out right around 100 to 800, maybe 1000 watts of power. And still, even from 24% battery power, this thing is estimating an hour remaining. So can it do it? It absolutely can. But it has been a really long day, and it is time for me to move on. So I'm going to try to run something just a little bit bigger with this thing. All right, we're rolling.
Is that a yes?
Yeah, just nice and slow so we can have time to update the current. It's a little laggy on the app. What are you doing? That actually caused it to shut off the AC output. Let's go ahead and turn that back on. We have a cut.
What you do with that hot?
I hear fanage running, so apparently it's getting a little bit warm. We're down to 99% battery power. All right, here we go for cut number 3. And I think we're going to move the PowerMax so it's not covered in sawdust. Okay, here goes cut number 4. All right, here goes cut number 5. So far, everything I've plugged into this thing runs exactly like it would if it was plugged into the wall. Wow, so there you go. This thing just cut 10 2x4s. And we're looking at 99% battery power remaining with an estimated 6 days. I kind of had my doubts that it actually would run like larger air compressors and big saws and stuff like that for any reasonable amount of time. But this thing really can do it. Well, so all that cutting, and we got her down to 95%.
Screws now, right?
Actually, it fits well enough to not even need screws. All right, here we go. This is the final 60-inch cut for this build. That's a lot of cuts. I've completely lost track of how many cuts. Like,
a lot.
That is completely nuts to be doing this on battery power. I think it's pretty safe to say we're not going to be using a generator the next time we have a hurricane. 93%. 5 days remaining. Hey, there you have it. There's what this thing built, and we managed to run it down to about 93% battery power. It would have actually built this whole thing several times before we ran it dead. So I want to do a much better test as far as this thing's total rated output power. It's rated for 3,600 watt hours, which would be 3,600 watts for a full hour. Now, it also says that it will do 3,000 watts continuous across these 120 volt plugs. Now, each one of my loads here are 1,500 watts. I've got 1,500 watts here and 1,500 watts there. That is if they're on their high setting. And I'm gonna see what this thing can do, if it'll really hold 3,000 watts of continuous output power. You can see I'm starting my shenanigans at 1:56 p.m. on a Saturday. I'm gonna go ahead and turn the AC outlets on here. We're at 99 days remaining at 100%. Now, with the AC outlets running at idle, we're looking at 5 or 6 days remaining. I'm gonna switch our first load on. So the first heater here, I'm going to put it on the high setting. That should give us about 1,500 watts. It is now on. Oh yeah, baby. 1,560 watts of output power. I can actually hear the fans on the machine starting to scream, which is good. Now, we're looking at 2 hours remaining at 1500 watts. That would be about 3000 watt hours. Let's turn that second heater on the high setting. Here we go. All right, now we are running 2 1500 watt loads. Wait a minute. Oh, it's got a safety switch on the bottom. Better push it down a little harder. Now we are running 2 1500 watt loads. Look at that. It is actually holding 3000 watts of output power, and it's still holding 120 volts on the inverter. Now, a lot of the inverters that I've ever used on battery power, when you start to load them down even a little bit, their output power drops significantly. We are sitting here estimating 1 hour remaining at 3000 watts, 99% battery power, 98% battery power. I'm actually just going to continue to let this thing run for a while here and see what it will do. I mean, it says it's going to run 3000 watts for an hour. So it's got a push-pull design here. It's sucking in air here and it's blowing it out here. And the air that's blowing out here on this side, it's a little warm. It's not really hot. So we're down to 92% battery power with an estimated 58 minutes remaining. And that is at 2:02 p.m. on Saturday. What is that, about the 7-minute mark, something like that, 7 or 8 minutes? No loud cracks or pops and nothing sizzling. There ain't no smoke coming out of it. The air coming out the exhaust side is starting to get just a little bit warm. There we go. Now we got the ambient temperature here warmed up to 70.0 degrees. It is pretty stinking remarkable to see 3000 watts being drawn off of this inverter, and it's still putting out a steady 120 volts. That's like pretty stinking excellent. All right, our ambient temperature now is up to 70.3 degrees at 2:05 p.m. We've got 55 minutes remaining and we're down to 88% battery power. Everybody in the state of Florida can thank me for raising the temperature up down here just a little bit. It's been cold. So during power outages, this thing will last my family a long time if we're not just like running space heaters or trying to keep the refrigerator going off of it. If we are just charging phones and keeping the lights going and, you know, charging a laptop and keeping our smaller electronics going, I suspect this thing will last us several days at least, probably 3 to 5 days. And once we do manage to run it down, well then we can just take it somewhere else and charge it. Now, if I do want to keep the refrigerator going or keep a deep freeze or something going like that, as long as we're not opening the door constantly, I mean, it should just hardly ever run the compressor, and then this thing will last a whole lot longer. During the last power outage, we actually knew it was coming because hurricanes are like getting stalked by like a giant turtle. We froze like a whole freezer full of 1-gallon jugs of water, and that gave us enough ice to where by the end of 5 days, we were just starting to run into the end of our cooling power. So if we do foresee an extended power outage, like I'm not planning on using this to keep our refrigerator running. We will just fill the refrigerator full of ice and not have to use this to do it. So we are about 5 or 6 minutes away from the 30-minute mark. And you can see we've got the entire state warmed up to 72.9 degrees. This machine is down to 62% battery power remaining, and it is estimating another 39 minutes. So we are now right at the 30-minute mark. We are at 2:27 p.m. The machine is estimating now 52% battery power remaining with an estimated 32 minutes, and that is drawing 3000 watts of power still. Holy smokes. Now, something really interesting is happening. The device that I have recording this video is almost dead, and I don't have any power out here. So I'm gonna go ahead and connect a charger. So now with my laptop charging at the same time, it's gonna crank its way up to, oh, that only added about 70 watts or so. I seen it just now at 3100 watts, and that does have the laptop charging at the same time. Now, let's just check the output voltage once more. Here, we'll plug in there. And plug in there. Oh, she just kicked out. There we go. That's all it could handle. So at 3000 watts, that put this thing like right on the edge of what it could handle. And by adding my laptop to the mix here, that was just too stinking much. I'm gonna disconnect one of those space heaters now and turn the AC outlet back on. Oh, and if I wasn't clear, what just now happened is the internal breaker on the inverter tripped and it turned those AC outlets off. So I just turned the outlets back on. We should go right back up to 1500 watts of power. And since I'm charging my laptop at the same time, it's actually drawing 1613 watts of power. We are now at 50% battery and it is estimating 1 hour remaining. This thing sat here and cranked out 3000 watts of power for a half an hour and used half of the battery. So if my math serves me right, that's about 3000 watt hours of output, which is right along the proper lines of what this thing is promising. I'm just genuinely happy that even with a 3000 watt load on the inverter is still able to keep up and put out 120 volts. It never dropped below 120 volts until it just kicked off and said, that's it, I've had enough. So out of curiosity, I am wondering if I were to kill the 1500 watt load, how long it says it'll run and charge just my laptop. We jump straight up to 13 hours remaining from 48%, and you can see my laptop, it's charging at about 100 watts. So for the final load test here, this isn't going to be a whole lot of a test. I really just want to make sure that this thing is sort of reporting all of the current together. So the first thing I'm going to connect here is going to be a MacBook to one of the fast charge USB-C outlets here. Let's give this thing just a second to realize that there's a charger hooked to it. I see that we dropped down to 5-7 days remaining, but it's not reporting any current. Maybe there's just not enough current yet. The battery in this MacBook, I believe, is almost charged all the way full. So here we go. So now it's beginning to register some output power on the USB-C ports. And I believe this battery in this MacBook is just about full. So also for this test, I'm going to hook up this really, really old spotlight. I'm going to hook this right here to the 12-volt cigarette lighter plug and turn that on. Okay, so with MacBook only hooked up, we're showing 24 watts. And now I'm going to turn on the spotlight. We get nothing. Let's jiggle the cord, right? Aha, there we go. Jiggle it a little more. Jiggle it a little more. This is not the fault of the cooler. This is the fault of my, well, this is like a spotlight from the Stone Ages. And there you go. We've got 90 watts of warmth burning my hand, or 80 watts. So we are actually reporting the output power on the DC side for everything combined. And if we disconnect the charging MacBook, it drops to just what we're getting on the spotlight. So I'm pretty well pleased with that. I'm not going to go any farther with the DC output testing. So in the beginning of this video, we did show how this thing charges using the AC power, how it charges all the way up to 1800 watts. Now, I have not yet demonstrated how this thing behaves if we try to charge it on DC power. I don't actually have any solar panels, so I'm going to be testing this using the car charge cable that came with this. Now, this thing should be able to pull about 10 amps of power through this plug. Hopefully it's smart and it realizes that we're using a lower voltage, so it doesn't try to pull so much that it's just going to blow the fuse on this car. I'm going to connect one end of this cable to the cigarette lighter plug. I'm going to connect the other end of the cable to the DC input on the back of the box. Let's see what happens. I heard a little bit of a click. We are ramping up and drawing 90 watts of input power, so that's actually looking pretty good. It's not just trying to like kill the fuse on the 12-volt plug. So let's see what we say for recharging minutes. I'm guessing it should be from 50%, should be around 16 hours remaining. I'm pretty sure if I leave this thing charging until it ticks up 1%, then we'll start getting more of an accurate estimated time remaining. But if my calculations are correct, it's gonna have to sit here and charge for like an hour maybe before I gain 1%. So I'm just not gonna wait on that. I think many of you watching this video are probably just a little bit curious as to what is inside of this box, and I am too, so I decided to take it apart just a little bit. Okay, they're all loose. I think from now it's gonna pop, snap and pop. All right, let me grab that stuff. Give it a little pop-a-roo. No, something's hooked.
Clearly.
That screw right there. All right, now we're good. So here's what this thing looks like inside. Needless to say, I'm actually not going to be taking this teardown very far, but I did have some genuine concerns about cleaning the fans, because this is something where, you know, it's got a 10-year battery in it, so there, at some point in time before these batteries go bad, you're going to want to be able to clean the fans. Now, at first I thought you would peel this little panel off the side, which it kind of seemed like it would pop loose, and I'm really glad I didn't try to pop it loose. Here's actually how you get in there. These side panels lift up and then they pull out, and that exposes what would be like where you would put a filter for the fan, only this is the exhaust side. You would want to do this on the other side for the intake. But I'm glad I didn't pry on that little orange grate any harder, because it's got screws in it. But the most awesomest, coolest thing about opening this side of this machine is that we can absolutely get a look at what batteries it has inside of there. And to be completely honest, I have no idea what kind of batteries that is. I just know it's not like some big old clunky car batteries or anything like that. And I also think I'm probably looking at some kind of a thermistor down in here for like thermal protection. I'm not going to be taking it apart any farther than this. I just really wanted to know what I had to go through if, you know, when it comes time to clean these fans, because there will come a time to clean these fans. This side here is really the side that should have some filterage going on, because this is, you know, this is the intake side, and it is the same way. It's got screws in it here, and no filter on the fans. So right here, this is where we're going to be collecting dust more than anything. And again, you can get a look at the batteries on this side as well. It looks like it's going to have one layer of those big old giant batteries, and I don't know, how many do we have here? We're looking at 1, 2, 3, 4, at least 5 wide, maybe 6 wide. I can see another one in there. 6 wide, and then basically the width of this entire machine. And oh yeah, I am taking it apart with it on like any responsible adult would do. So putting this stuff back together, it's exactly like it came apart. It sort of goes back together like a laptop or the side of a PC case or something, where you want to get it all lined up and make sure it's pressed in from the top to the bottom all the way, and then it just pops right down on its latches. See, it's got these little hooks that all got to hook in just right, and then they just slide right down in place. So same exact thing on this side. Get it right there in place, and then it just pops right down on there. And the lid also has snaps all around the outside, so not much to it. Snap the lid back on it, put the screws back in. So I didn't tear it down any farther than that, because I really don't want to cause any damage, and I would have had to start disconnecting cables and things that had little dots of glue on them, and I really just wanted to have a tiny little bit of a peek inside this thing. So this device comes with a 4-year warranty, and they say 24/7 online tech support. The company has a warehouse in the United States and Europe, and they have a service center in the United States and in Germany. Now, one thing that I did not demonstrate, and that is inside of the app, we can actually adjust the charging power, because there are times whenever you're not going to want this thing just to crank away and draw 1,000 watts, and actually right now is one of those times. So I'm going to be turning this thing down to, let's say, 400 watts of charging power, and then give it just a second to realize I've plugged in a cord. And there you go. We can see it's drawing 250 watts. So far, my experience is that the charging current limiter has been about 100 watts off. The last time I set it to 400 watts, it was drawing 500 watts. But nevertheless, you can actually change the input power. And there we go. We're charging at 450 watts. And if we want to raise that up a little bit, like say 800 watts, give it just a second to register. I hear the fans kicking in and spinning. and then the wattage is going up. But with everything I have running right now, I really don't want it to sit there and crank away at 800 or 1000 watts. So I'm gonna let that charge at 400 watts. So my biggest complaints with this thing are the fans. There really isn't anything in the way of filtering the air that's coming into this thing, but from what I've seen taken apart, it's pretty easy to get into to clean it, and it's also really easy if you wanted to add just like a really thin mesh just over the outside of it without taking it apart, you could do that. So the fans really are not a big concern. One of the main questions that I have for myself is whether or not I can get this thing to work with Home Assistant. I think it would be really cool to be able to have some charting as far as energy consumption coming, going out, as well as charging power coming in. And just when you hook something like this to Home Assistant, you get all these cool graphs and stuff like that. So I do have some digging around and work to do to see if that may be possible. The only other thing I could think of to mention is that the app control, again, it's using an external server, so it is requiring internet access for this to be able to work. I'm not sure if this app will work just directly with Bluetooth directly to the unit or not, but it looks like to get the app to work, you have to pair it up with your, with your Wi-Fi, and then the app works, which means if you have it paired at home and then you leave and take it on a trip, then you're going to need to repair it and do something differently with the app. Otherwise, it's going to be disconnected after you leave your home hotspot. So I think that pretty well sums it up for this review. This is a stinking awesome product. We're going to be using this instead of a generator whenever there are power outages, and I may actually wind up using a generator to charge it whenever the noise is a little more convenient. Generators can be really stinking loud, and during our last power outage there was times whenever we didn't run the generator whenever we wanted to. I had a single deep cycle marine battery that we were using on a 700 watt inverter, and that's what we used primarily to run lights and keep stuff charged. So I'm pretty stinking excited to have this thing. Everything that I plugged into this has ran exactly like it is supposed to, and I just don't really have any complaints. So I really want to thank Blackview or Oscal, whichever one or both of you, for sending me this product for review. I absolutely love this thing, and I'm going to put it to good use. Now, if you like this thing and you're interested in purchasing it, I'm going to leave a link in the description down below to get to their page for this, and it should give you all the information you need. And that is it for now. I will see you in the next one, everybody. Have a good day. This will do good in the shower, right? Like, yeah? Good, huh?